Saxon Algebra 1, Lesson 74. Greetings, students. How are you? I'm good. The snow is melting and that makes me sad. But, you know, I'm happy that we had this time together. So, our time with the snow. I've been making the most of it. I love snow. I grew up in snow. I wish we had more snow. But you know what? I'll take what I can get. You want to talk about scientific notation? Oh, yes, you do. It's going to be fun. I don't know for sure what you remember about scientific notation, so I'm going to start at the beginning. If you've already heard this and already remember it, that's fine. You can sleep during those parts. Just kidding. Don't sleep. But I'll remind you, it's good for very large and very small numbers. It is essentially a way to code these numbers so we don't have to write like a ton of zeros, all right? So it's good for very large or very small. It's very useful in the fields of astronomy, where things are very far away, so we have big numbers, or chemistry, where we sometimes have big and sometimes have small. It's also useful for biology. Okay, lots of sciences. Those are just some examples. And that's the way I think of it. It's a code. It's a secret code. And sometimes we put numbers into the code. We put regular numbers into the code. And by regular, there's a special math phrase for that. We call it standard form. And we call this scientific notation, right? So we put standard numbers into scientific notation, but then we have to learn how to do the reverse, right? We have to learn how to put coded numbers back into, and now I'm going to use the math word, standard form, also known as regular. Okay? So we have to learn how to do both. And sometimes that blows students' minds a little bit because they get it one way and not the other way. All right, let's look at what the code looks like. In the code, the largest digit of the number that we're talking about goes in the ones place. Here's a big fat decimal. It's okay to have digits going into the decimal land, but the largest digit in the number goes in the ones place, okay, right there. And sometimes we add the word the largest significant digit, because you will see, and I'll point it out to you when we get there. Sometimes there are zeros that would go over here, but we just ignore them. All right, so by significant, I mean non-zero. Okay? So we take a number and we make it so that the digit in the ones place is the biggest digit, and then we can have all of those. Then we multiply it by 10 to a power. Okay, this is the form. This is the coded form that we put all the numbers in to say that they're in scientific notation form. All right, let's practice doing one. We're going to take a very small number, 0.000316. This is a cumbersome number. It's got a lot of zeros. I had to count carefully. There's extra writing that's involved. I don't want to use a number in that form. I would rather put it into scientific notation. So here's the way we do that. First, we find where the decimal is now. Right there. I'm going to make it in blue. Then we jump as many times as we need to in order to put the decimal in where we want it, which is right there. Notice how 3 is the first significant digit. These are important digits in the number, but they are 0, so they're not significant digits. So we want to move the decimal there. We have to jump it 1, 2, 3, 4 times. Okay, so that tells us that our number is going to be, there it is, 3.16 times 10, and now it was 4 jumps, so I put the 4 here, but I'm not quite done. 3.16 is the number that we have when we adjust the decimal so that the largest digit is in the ones place. And there I wrote it that way. I just put in 3 point and then everything else just fell into line. And I'm multiplying that by 10 to the 4. That represents the number of jumps, right? Now, here's the trick. When we're putting a number into the code, the minus sign is there, the minus or plus sign is there to help us when we move this number back into its standard form, okay? So if we have a positive here, that means make the standard form number greater than the scientific notation number. Okay, so if we leave this as a positive 4, that's telling us move it 4 jumps, but make this number greater. And so we would move it that way, 4 jumps. That's not what we want. We want to make this number smaller when we turn it back into that. So the minus sign tells us make the standard, whoops, I spelled this wrong, form number less than the scientific notation number. Okay, so we want a minus sign here because that tells us, okay, when we move the decimal, we want to make this smaller, lesser. So we would move it 1, 2, 3, 4 that way, and that would get us back to this number. So that's how we know whether to put a positive or a negative there. We use these rules. When I put it back into a standard form number, do I want to make it bigger or greater or lesser than it looks in scientific notation? Okay, let's do another one. Example 74.2, and there are a total of 4 problems and then we're done. Write 0.000. Okay, now this is quite common in the world of scientific notation. We're supposed to write this in scientific notation. This looks familiar, but this needs to be fixed, doesn't it? So before we can deal with that, we just focus on this much of it, all right? And we write this much in scientific notation, which we just did, by the way. 1, 2, 3, 4. So it's 3.16 times 10 to the minus 4. The minus sign tells us to make this number lesser when we blow it back up to standard form. That means we would move it this way, 1, 2, 3, 4, and yes, that's what we want. So the minus sign is right. Okay, so we turned this number into this, but now we have to take this into consideration. So what we do is we bring it down here. Now we can combine these two. 3.16 stays the same. And we know, because of the product rule for exponents, that if we're multiplying a matching base, we add the exponents. So that's our final answer. Okay? I'm not sure if this is new to us. I think this is new to us. We're going to be doing lots more of this. 74.3. Write 0. This number again times 10.7. Now we're supposed to write this in scientific notation. All right. So we know how to do this. 1, 2, 3, 4. We know this is 3.16 times 10 to the minus 4. The minus sign tells us to take this number and make it smaller by 4 jumps. Okay. And now we know, first we do that. Then we pay attention to this. times 10 to the 7th. Now we can do this much, 3.16 times, and we add those two. It's a negative number, but that does not hurt us one little bit. It's 10 to the 3rd power. Yay. And our final problem is now we're going the other way. No, it isn't. It's this. Oh. This one has an A, B, and C, which I think is very cheatery, but that's okay. They're kind of related. Write the following numbers in scientific notation. 47,800. Okay, we have to put this into the code. That means we want to move the decimal to this place. It's already right here. Sometimes you have to draw the decimal in. In some numbers, it already exists. In some numbers, it doesn't. We have to add it. So we're going to move it 1, 2, 3, 4 jumps again. So we'll write this with the decimal there. 4.78 times 10. And we said 4 jumps. But this time, this number needs to get bigger when we put it back. So we want this to be positive because this number needs to get bigger when we put it back into its standard form. So that's how we know to put a plus sign up there. This is the hardest part. The sign on the exponent is what makes everyone want to cry. B. 47,800 times 10 to the minus 7. Okay, once again, these are like what we did here. First, we fix this much, which we already know how to do. 4.78 times 10 to the positive 4. I like to put the plus in there just so it's crystal clear. And then, when we multiply it by 10 to the minus 7, that means we'll add the exponents here. It becomes 4.78 times 10 plus 4 minus 7 gives us minus 3. Yay. And then we'll do C right here. And this is 47,800 times 10 to the 7th. This times it's a positive 7. We know how to do this. This is 4.78 times 10 to the 4th, right? See how we did this first, and then we can use this for the other parts. And then we're multiplying it times 10 to the 7th. So now we're combining those. 4.78 times 10. We add them because this is the product rule. 10 to the 11th, and that's our final answer. All right. That is lesson 74, but I promise you that is not the end of scientific notation. Once we get the hang of moving in and out of the code like this, like we were doing here, then we're going to practice putting numbers into scientific notation, then multiplying or dividing them, and simplifying our answer. So we haven't begun to operate yet. We're just practicing the code. Okay? The last thing I want to remind you, and this use of the product rule here reminds me to remind you, which sounds like telephone tag, that you're memorizing this chart this week. The rules for exponents. See, we just used this one. When we have like 10 to the 4th and 10 to the 7th, and we're multiplying those, we can simply add the exponents. So you guys, we're using these rules all the time, and that's why it is so important that you memorize them so you know exactly what they are. And then when you stumble upon them in a bigger problem, your brain has something to grab hold of, right? Your brain knows, oh, I got it. This chart is in here. Let me dig it out. And once I have this chart in my mind, then I know exactly what I'm doing. For example, in scientific notation, when we're simplifying the exponents on the power of 10, like we were doing there. This chart is so important. Trust me, please memorize it. I can't wait to talk to you on Friday or Thursday, and whichever the case may be, and have you fill it in and get it perfectly right. Okay, lesson 74. Thank you. Goodbye.